In this video, we're going to talk about how to divide polynomials using synthetic division. Synthetic division is a useful method for dividing polynomials when the divisor is linear and the coefficient of x is 1. For instance, if the divisor is x minus 1 or x plus 2 or x minus 10, etc., we can use synthetic division. Most students consider it faster and easier when you can use it. Let's use synthetic division to give the multiplication statement and the division statement for the following. X cubed plus 2x squared minus 10x plus 7 quantity divided by x minus 4. The divisor is x minus 4. We're going to ultimately put a 4 to the left of the synthetic division sign. The reason why we do that is for some students they think they change the sign, and others will say what we're going to do is imagine solving the equation x minus 4 equals 0. However it is that you think of that, when you see a divisor of x minus 4, put a positive 4 next to the synthetic division lines, and then put the coefficients of the dividend in to the right, as we've done here. So again, x minus 4 means we put a 4 to the left of the synthetic division lines, and 1x cubed plus 2x squared minus 10x plus 7 means we put a 1, a 2, a negative 10, and a positive 7 to the right. Now, we bring the 1 down, and then we multiply 4 by 1 and put it under the 2. So 4 times 1 is 4. By the way, it's this 4 and this 1 that we're multiplying. 4 times 1 is 4, and so we put that under the 2. Now we add the 2 and the 4. Okay, so we add that 2 and that 4, and we get 6. Now we're going to multiply the 4 by the 6, and we're going to put it under the negative 10. Now we're going to add the negative 10 and the positive 24. When we do that, we get 14. Now we're going to multiply the 4 by the 14 and put it under the 7. And we get 56. And finally, we will add the 7 and the 56, and we'll get a 63. The remainder is 63. That's this part right here. The 1, the 6, and the 14, they represent the coefficients of the quotient. The degree of the quotient will be 1 less than the degree of the dividend, because when we divide anything by a linear, you get 1 degree less than the dividend you started with. So in this case, when we divide a cubic by a linear, we get a quadratic. So therefore, the quotient is going to be 1x squared plus 6x plus 14, and the remainder is going to be this 63 right here. So looking at it again, the divisor is x minus 4, the quotient is x squared plus 6x plus 14, the remainder is 63. Recall the dividend was x cubed plus 2x squared minus 10x plus 7. And we can give a multiplication statement, and we can give a division statement. The multiplication statement is always dividend equals divisor times quotient plus remainder, or you could say quotient times divisor plus remainder. And the division statement is always dividend divided by divisor is equal to quotient plus remainder over divisor. So let's try another one. We'll use synthetic division to give the multiplication statement and division statement for x cubed minus 12x squared minus 50x plus 17 divided by x plus 3. Well, going through this quite a bit quicker, the one thing I'll point out is when you have a divisor of x plus 3, you put a negative 3 to the left. We see that our coefficients of our divisor are 1 and negative 12 and negative 50 and positive 17, so they go here. We bring the 1 down. Negative 3 times 1 is negative 3, and then we add negative 12 plus negative 3 to get negative 15. Then negative 3 times negative 15 is positive 45. We add that column, negative 50 plus 45 is negative 5. And then that negative 3 on the far left times the negative 5 is positive 15. And we add that last column, 17 plus 15 is 32. we started with a cubic, meaning that our quotient will be a quadratic, 1x squared minus 15x minus 5. Our remainder is 32. So our multiplication statement will be x cubed minus 12x squared minus 50x plus 17 is equal to the quantity x squared minus 15x minus 5 times the quantity x plus 3 plus 32. And our division statement is x cubed minus 12x squared minus 50x plus 17 over x plus 3 is equal to x squared minus 15x minus 5 plus the remainder of 32 over the dividend of x plus 3. Now let's use synthetic division to give the multiplication statement and division statement for x squared minus 9x plus 14 divided by quantity of 2x plus 5. Well, this one's a bit different because the coefficient of x in the linear divisor is 2. So what we're going to do is we're going to let the divisor equal 0 and solve for x. Letting 2x plus 5 equal 0 means that 2x is equal to negative 5, which means that x is equal to negative 5 over 2. So what we're going to do with our synthetic division is we're going to divide by x plus 5 halves, not by 2x plus 5. It's important to keep that in mind. Our synthetic division is made to assumes that it's a coefficient of 1 in front of the x. So just keep in mind we're actually dividing by x plus 5 halves. We'll do that, and then at the end we'll take that into account and adjust our answer. So if we have dividing by x plus 5 halves, we've got a 1, a negative 9, and a 14. We bring the 1 down, and we've got negative 5 halves times 1, which is negative 5 halves. Now, negative 9 plus negative 5 halves is negative 23 halves. Negative 5 halves times negative 23 halves is 115 over 4, and 14 plus 115 over 4 gives us 171 over 4. When you take a quadratic dividend and divide it by a linear divisor, you're going to end up with something linear. So what we've just established is that x squared minus 9x plus 14 is our dividend. Our divisor is x plus 5 halves. Remember, we're not quite dividing by 2x plus 5. Our quotient is going to be x minus 23 over 2. It's 1 degree less than the dividend. And our remainder is going to be 171 over 4. Okay? So, keeping all that in mind, this is what we get. X squared minus 9x plus 14 equals x plus 5 halves times x minus 23 halves plus 174. And our division statement is x squared minus 9x plus 14 divided by x plus 5 halves equals x minus 23 over 2 plus the remainder of 171 over 4 over the divisor of x plus 5 halves. Now, that's not quite what we were asked to do. So what we're going to do is we're going to multiply that, look at the multiplication statement, and we're going to say we wanted that not to be x plus 5 over 2, but instead we wanted it to be 2x plus 5. So we're going to multiply it by 2. But if we multiply that by 2, we have to divide that other factor by 2 to account for the fact that we multiplied by 2. So say, for instance, if this helps explain it, that's good. I hope this doesn't confuse it. Let's say, for instance, I told you that 30 is equal to 3 times 10. You'd say, okay, that's fine. Now, if I multiply this 3 by 2 and get 6, I have to divide this 10 by 2 and get 5. And I can say 30 is equal to 6 times 5. And that's correct. So if I'm going to be multiplying that by 2 to make it equal 2x plus 5, I better be dividing that by 2 to account for the fact that that's what I did a second ago. So I put a 2 there and a 1/2 there. And then I can say, in other words, we're multiplying the whole expression by 2 and then by 1/2. Distributing both of these in, I get 2 times x plus 5 over 2 is equal to 2x plus 5. And then I get 1/2 times x minus 23 over 2 is equal to 1/2 x minus 23 over 4. And that is our multiplication statement. So we can use synthetic division to divide by 2x plus 5, but we have to take something into account at the end. Now let's take a look at our division statement. Our division statement is x squared minus 9x plus 14 equals x plus 5 over 2. X squared minus 9x plus 14 divided by x plus 5 over 2 equals x minus 23 over 2 plus 171 over 4 over x plus 5 halves. The problem is, I didn't want to divide by x plus 5 over 2. I wanted to divide by 2x plus 5. So what we're going to do is we're going to multiply this denominator by 2. But if I multiply that denominator by 2, I need to multiply every other denominator on the other side by 2. Another way of saying that is, remember, multiplying a denominator by 2 is the same as dividing by 2. Another way of saying that is I divided the left-hand side by 2. So I better divide every term in the right-hand side by 2 as well. Okay? So that's what I do. I divide every single one of those terms by 2, or another way of saying that, multiply every denominator by 2, and I end up with this as my division statement. However, I see that I've got a fraction in a rational expression. I don't like that. So let's multiply numerator and denominator there by 4. And when we multiply 4 by 2x plus 5, we then can multiply 4 by 171 over 4, which equals 171. And we get our final division statement as shown. And that is the end of our slideshow.